Alright guys, it's Mrs. Crocker here. I'm going to walk you through the notes for today, independent dependent events. So what we're going to focus on is we're going to focus on differentiating between an independent and dependent event and then finding the probabilities of them. So when we talk about independent events, this is when the occurrence of one event does not affect the probability of another. If two events A and B are independent, then the probability of them both occurring, so the probability of A and B, is just the probability of A times the probability of B. Okay, so if these two events are independent, that means that A occurring does not affect B. So you're just going to multiply the two probabilities, and that's going to give you the probability of them both occurring. So when you look at example 1, if a coin is tossed twice, find the probability of tossing heads twice. So if a coin is tossed twice, it's landing heads up on the first toss and landing heads up on the second toss are independent. The outcome of one toss does not affect the probability of heads on the other toss. Okay, so these two probabilities these two events are independent from each other. Getting a heads on the first toss doesn't now affect you maybe getting a heads on the second toss. So what you're going to do to find the probability of heads and then heads, you're just going to multiply the probability of getting a heads times the probability of getting a head. Because remember, they are independent events. So when they're independent, you just multiply the two probabilities. So if I'm flipping a coin, the probability of getting a heads is 1/2. Then the probability of getting another heads is 1/2. So the probability of getting two heads would be 1/4. All right, so on 2, it says a number cube is tossed twice. Find the probability that the first number is greater than 2 and the second number is even. So what you're doing here is you're finding the probability that a number is greater than 2 and then the probability that a number is going to be even. These are going to be independent from each other because if my first toss of the cube is not going to affect my second one. So to get the probability that a number is greater than 2, think about your sample space. If I'm rolling a number cube, it could be 1, 2, 3, 4, 5, or 6. Okay, so you have 6 numbers in your sample space. And how many of those are going to be greater than 2? That would be if I rolled a 3, 4, 5, or 6. So that's going to be 4 total out of my 6. And then the probability of getting an even number, that's going to be my 3 total out of 6. Okay, because I could get a 2, 4, or 6. So what I'm going to do to find the probability of both of these things happening is I'm going to multiply my two probabilities. So I would end up with 12 over 36, which would reduce to 1/3. Okay. Now in B, it says find the probability that the first number is 4 and the second number is less than 3. So what I'm going to do, these are independent. So I'm going to find the probability of getting a 4 and then find the probability of getting a number less than 3, and I'm going to multiply them. So the probability of getting a 4 would be 1 out of 6. The probability of getting a number less than 3 would be a 2 out of 6 because you could roll a 1 or a 2. So when I multiply these two probabilities, I would get 2 over 36, which would reduce to 1 over 18. All right, now on 3, a jar contains 2 red marbles and 3 green marbles. One marble is selected at random and replaced. Then a second marble is selected. So if you think about what we're doing here, we're taking a marble out, but then I'm replacing that marble. So since I'm replacing that marble, this is what's going to make these independent events. Because what I pull out from the bag or the jar on the first pull isn't going to affect what I do on the second one because I put whatever I got back so that I still have the same sample space. So if I want to find the probability that the first marble is green and the second marble is red, meaning I want the probability of a green and then a red, what I'm going to do is I'm going to multiply the probability of getting a green times the probability of getting a red. So if I have 5 marbles total and 3 of them are green, this is going to be my probability of getting a green, 3 out of 5. And then the probability of getting a red would be the 2 red out of 5. So in total, our probability of the first one being a green and the second one being red would be 6 out of 25. Now, if I want the probability that both marbles are red, what I'm going to do is I'm going to take the probability of getting a red marble, which is 2 out of 5, times the probability of getting a red marble, which is 2 out of 5. Okay, now notice these probabilities are the same. That's because when I pick the first red marble, I then put it back, so the probability of getting a red marble again is the same. Okay, because you have 5 marbles total and 2 of them are red. So your probability of getting a red and then another red would be 4 out of 25. Why don't you go ahead and try C there? So if you want the probability that both marbles are green, I would take the probability of getting a green, which is 3 out of 5, times the probability of getting a green, which is 3 out of 5, so it would be 9 out of 25. All right, so in number 4, it says events A and B are independent if the probability of event A is 0.2 and the probability of B is 0.7. What's the probability of A and B? So remember, if these events are independent, then that means the probability of A and B is going to be equal to the probability of A times the probability of B. So if the probability of A is 0.2 and the probability of B is 0.7, when you multiply them together, it gives you the probability of A and B to be 0.14. On 5, it says events C and D are independent. Okay, they're telling you they're independent. It tells you the probability of C and D is 0.8. And the probability of D is 0.5. You want to find the probability of C. So remember, if these events are independent, that means the probability of C and D occurring is the probability of C times the probability of D. So just plug in the pieces you have. You know the probability of C and D is 0.8. You know the probability of D is 0.5. So now if I want to solve for my probability of C, what am I going to do with this 0.5? If I'm multiplying it in order to undo it, I would divide it. So the probability of C happening would be 0.16. Okay? Now, if we are talking about dependent events are when the occurrence of one event affects the probability of the other event happening. Okay? So independent, there was no effect from one event to the next. But when you're dealing with a dependent event, the event or the occurrence of one event is going to affect the probability of the other. So if 2 events are dependent events, then the probability of both occurring, the probability of A and B, is going to be the probability of A times the probability of B after A has occurred. So this right here, this probability of B after A has occurred, is kind of like our conditional probability that we did on the last one, on the last notes. So in many cases that involve random selection. Events are going to be independent when there's replacement and dependent when there's not replacement. So if I'm dealing with marbles and I'm picking marbles out of a jar or whatever and putting them back when they're replaced, that makes the events independent. But when I'm dealing with marbles and I'm taking them out and not putting them back, they're not replaced, now that makes the dependent event. Okay? So let's try some examples. Number 6, a jar contains 2 red marbles and 3 green marbles. One marble is selected at random and it is not replaced. Then a second marble is selected. So when I want to find the probability that the first marble is green and that the second one is red, what you're going to do is you're going to multiply by the probability of getting a green. Okay, so the probability of getting a green would be 3 out of 5. And since the first marble is not replaced, there are only 4 marbles in the jar for the second selection. So I have taken 1 green marble out of the jar. So now I only have 4 marbles left. And if I want to know how many of them are red, well, I have 2 red marbles and my first one was green. So I still have 2 red marbles out of a total of 4 marbles now. Okay, so you're multiplying the two probabilities, but your second probability is given that the first event has already occurred. So this is the probability of a red, this right here is a probability of a red given we've already gotten a green. So I've taken a green out, now there's only 4 marbles and 2 of them are going to be red. So your probability would be 3 out of 10. If you want the probability that both marbles are red, you're going to find the probability of getting a red. So there's 2 red out of 5 total. And again, there are only 4 marbles in the jar for selection, for my second selection. Okay, I took 1 red one out. And because the first marble selected was red, there's 1 less red marble remaining. So now for my second red, so getting my second red, I only have 4 marbles left, and only 1 of them is going to be red because I already took out 1 red marble. So the probability of getting a red and then another red would be 1/10. If you want the probability that both marbles are green, the probability of getting a green first is 3 out of 5. And now there's 1 less marble, 1 less green marble for your second selection. So your second selection, there's only 4 marbles left, and only 2 of them are going to be green. So the probability of getting both green marbles would be 3 out of 10. All right, number 7, 8 balls numbered 1 through 8 are in an automatic random selector. A ball is selected at random and it's not replaced before a second ball is selected. Find the probability that the first number is odd and the second number is even. So think about it. You're pulling out a ball and it's going to be numbered 1 through 8. So if I want the probability that my first one is going to be odd, my odd numbers would be the 1, 3, 5, 7. So there's going to be 4 odd numbers out of 8 total. Now, since the first ball is not replaced, there are only 7 balls remaining for the second selection. So if I want the probability of getting an even number, I'm going to have to now have 4 possibilities out of 7 total. So our probability of getting an odd and then an even would be 2 out of 7. All right, so the probability that the first number is 4 and the second number is less than 4. So the probability that the first number is 4 is going to be 1 out of 8 balls. Again, there are only 7 balls remaining for your second selection. So you could have 3 that are less than 7, that are less than 4 out of your 7 marbles total. So you would end up with 3 out of 56 for your probability. If you want the probability that both numbers are even, there is the probability that they're even is going to be 4 out of 8, but now there's 1 less even number for your second selection. So now there's going to be 7 balls left, and only 3 of them are going to be even. So your probability would be 3 out of 14. Okay, for numbers 8 through 12, I want you guys to go through and figure out if they are independent or dependent, and then I'll go through and show you the answers. All right, so a coin comes up heads and a number cube rolled at the same time comes up 6. Those are going to be independent events. The occurrence of one does not affect the other. Number 9, a 4 is drawn from a deck of cards, set aside, and then an ace is drawn. Now this key right here is telling us that they are dependent because I am not replacing that 4, and then that's now going to affect my sample space for my next pull. A 1 is rolled on a number cube, and then a 4 is rolled on the same number cube. Those are independent. Rolling a number cube and then rolling that same one again is going to be independent. A dart hits a bullseye, and the second dart also hits a 20, independent. Hitting a bullseye does not affect you hitting a 20. Bag contains 9 slips of paper 1 through 9, selecting 2 even numbers when 2 slips are chosen without replacement. That without replacement tells you they are going to be dependent. Okay, so let me know if you have any questions on any of these. There is an assignment that goes with this, and then there's a weekly quiz as well. So reach out with questions, and I will talk to you guys soon.